Hey everyone, it's Justin again. In the last video, you learned what arithmetic sequences are and how to find more terms. In this video, you're going to learn how to read and use formulas for arithmetic sequences. Before we get into the equations, there's some notation we got to be aware of. The A's here are read as term, and the subscripts tell us which term it is. So this first one says the first term is 2. The next one says the second term is 5, on and on. This is a way of denoting which term a certain value is, so we don't have to have the entire sequence in front of us. We don't need to see the entire list of 7 or more numbers in the sequence to know that the 7th term is 20. When working with sequence formulas, you'll see terms like these a lot. This one, a sub n, means term number n, or any term in the sequence. We could plug numbers into the n to denote any term, like first term, third term, 182nd term. Treat this nth term as kind of like f of x, but for sequences. This term, the nth minus 1 term, is better interpreted as the previous term. It just means whichever term came before the one you're looking at. If you want the third term, then the previous term would be the second. If n is 8, then n minus 1 is 7. And if you're trying to find the 182nd number in the sequence, then the previous term would be the 181st. Finally, the variable d is used to mark the common difference. Whatever d is, that's how much is added or subtracted from one term to the next. There are 2 forms that arithmetic sequences can be written in. First is recursive form. Recursive form looks something like this. Let's read this notation using what we just learned. A sub n means the nth term, or any term. A sub n minus 1 means the previous term. And d is the common difference. So we would read this as any term in the sequence is equal to the previous term plus the common difference. Here's an example of an arithmetic sequence in recursive form. Any term is equal to the previous term plus 4. We want to find the 5th term, which is equal to the 4th term plus 4. So to find the 5th term, we'll need to know the 4th term, which is 4 more than the 3rd term. And that requires us to find the 3rd term, which requires the 2nd term, which requires the 1st term. The 1st term can't have anything before it because it's the 1st. For this reason, no sequence can exist without knowing what the 1st term, or the initial term, is. So that will always be given to you. Now we know that the sequence starts with -5, then adds 4 each time. So the 2nd term is -5 plus 4, which is -1. The 3rd term is 4 more than that, which is 3. The 4th term is 7, and the 5th term is 11. This process of doing the same thing over and over again is called recursion, which is where recursive form gets its name. Here's another example. A sequence where any term is the previous term minus 3, and the first term is 70. If we want to find the 8th term, we start with the initial term and use recursion. The first term is 70. The second term is that minus 3, which is 67. The third term is 64, then 61, 58, 55, 52, and the 8th term is 49. The other way you may see arithmetic sequences is in explicit form, which looks like this. We already know that a sub n means the nth term, or any term. D is still the common difference, and a sub 1 is the first, or the initial term. As for the n minus 1 part, that's just where we plug in the value of n as if it were a function. Here's an example of an arithmetic sequence in explicit form. To find any term, say the 7th term, then we would consider n to be that number, 7. Then it's as easy as substituting that value for n and then solving. Inside the parentheses, 7 minus 1 is 6. 2 times 6 is 12, plus 1 is 13. So in this sequence, the 7th term is 13. Did you notice anything weird? With an explicit formula, you don't have to work through all the previous terms. You can just jump straight to the term you want. Explicit formulas are much quicker, especially with higher terms. If we have a sequence that starts at 6 and has a common difference of 3, how would we find the 53rd term? We could try using the recursive formula, but that requires us to work through every term leading up to the 53rd. We start with 6, then add 3, and add 3 again, and again, and again, over and over, never stopping until you've got a list of 53 numbers. This will take a long time. Or you could use the explicit form to jump straight to the 53rd term. Plug in 53 for n, and then simplify. The 53rd term is 162, and we found it pretty darn fast. Can you imagine how long it would take to get to 162 using the recursive form? Now that you know how to use both recursive and explicit formulas for arithmetic functions, next, you'll learn how to write the formulas yourself. See you then!